Hello, Year 7, and welcome to Week 3. Hope you enjoyed your Easter holiday break and you managed to stay safe. We're on to Week 3 now, and this is Lesson 1, Loudness and Pitch. This is the third lesson in our sound topic. So, today, what we're going to be looking at is the link between loudness and amplitude, the link between pitch and wavelength and frequency. We're going to look at how sound is measured, how loudness is measured, and then last but not least, we're going to look at the range of frequencies that humans and animals can hear. So there's going to be a few tasks for you to do after watching this lesson. Make sure you're downloading the worksheets to complete, and also download this PowerPoint, because there are some links on this PowerPoint that I'll point out that you can follow for some activities to do. But get started. So, loudness and energy. So, the more energy you use to create the vibrations, the louder the sound. So, my example, and it's a quality example, is the animal. The Muppet puts a lot of energy into hitting the drum, and he's going to make a much, much louder noise than that moth, because the moth is tinier, it's smaller. So the energy it's putting in is therefore going to create a smaller vibration and therefore a smaller sound. And the Muppet, he's putting in a large amount of energy, which means his vibration that he is making on the drum is going to be much larger, which means the vibration in the air is going to be much larger, and therefore the sound is going to be much larger. So, key note from this slide, the more energy used to create the vibration, the louder the sound. So, how does that link to a sound wave? It links to the amplitude. So what I've done here is I've shown you a transverse wave at the top and then the longitudinal wave at the bottom. So in an oscilloscope, the machine that we use to demonstrate sound, it shows the sound as a transverse wave, even though the sound wave is a longitudinal wave. So for this example, we'll use transverse waves to see the sound. So the louder the sound is, the higher the amplitude in a wave. So the louder we can make the sound, the higher the amplitude is going to be. So as you see, the increase in pressure increases the amplitude, and that's the compression part of a sound wave. And so the amplitude increases, therefore making a louder sound. So the taller the wavelength, the taller the wave, the louder the sound. And the smaller the wave, the lower or the smaller the sound. At the end of this video, there is a demonstration using an oscilloscope, and you can see very clearly what happens when we increase the amplitude. The sound gets louder. So, low volume, amplitude is much smaller, and then the high volume, the amplitude is much, much greater. So, the key thing to notice there, though, with both of those, is that wavelength is the same. Wavelength is not changing on either of these waves. They are both the same. The only difference in these two waves is that one is louder than the other. They will have the same pitch. So they'll have the same pitch, but one will be louder than the other. It's like playing a note on the piano. You play a note softly, or you smash a note down and play it loudly. It's the same note, it's just that one is louder than the other. So, the more energy you use, the higher the amplitude of the sound wave. So that higher amplitude means a higher volume. So watch the end of this video to see the oscilloscope of that happening. Now, pitch. I'm going to try not to sing in this too much because my singing voice is atrocious, but I will need to sing a little bit in order to demonstrate this. So with a high pitch, it has a high frequency or a short wavelength. Now, if you remember from previous lessons, the frequency is the amount of waves per second. So the wave on the left that we can see, it's got a much shorter wavelength and a higher frequency. It means that more waves will pass you by in a given second. So it might be 20 hertz, which would be 20 waves per second, as opposed to the wave on the right, which might be 5 hertz, which would be 5 waves per second. So a low pitch sound is going to have a low frequency and a really, really long wavelength. So you're going to have less waves pass you by in a given second because the wavelength is much longer. So a high pitch is going to have high frequency and a very short squished in wavelength, and then a low pitch is going to have a low frequency but a very long wavelength. So, as I just mentioned on the previous slide, frequency is measured in hertz, or Hz. So hertz is the amount of waves per second. So 1,000 hertz is 1 kilohertz, which would mean that there is 1,000 waves passing by a given point in 1 second. So make sure you've got a note of that. Frequency is measured in hertz, and it is waves per second. So every musical instrument or type of sound has its own individual waveform. So here what we look at is some of the different types of waveforms of different instruments. So in the top one, we've got what a flute sound looks like. A flute wavelength looks like. Sorry, can't see sound, obviously. In the middle one, we've got a piano's wavelength. And then on the bottom one, we've got a trumpet's wavelength. So notice just how different each of those waves are. So we're now going to look at the frequency range, or the range that human hearing can hear. So the audible range of a human hearing is the limit of how high and how low humans can hear. So you guys, you can usually hear anything up to about 20,000 hertz or 20 kilohertz. While as me, because I'm over 18, surprisingly, I know, I've lost the ability to hear higher frequencies. So my hearing stops at about 16,000 hertz. I have quite poor hearing, while you guys should be able to hear over 20,000 hertz. So you should have downloaded this PowerPoint before you watched this video. So what I want you to do is, once you finish watching all this video, pop back over that PowerPoint, follow the link on this slide, and have a look at this hearing test. It's quite interesting. See how high a pitch you can hear. So if we're talking about other animals though, dogs and bats can hear much higher frequencies than humans. So we've got quite a low frequency hearing range as opposed to dogs, which is why you might see people in the park blowing on whistles and you can't hear the whistle, but then their dog comes running. That's because that pitch is higher than our audible range, but not higher than a dog's audible range. And then if we go on the opposite end of the spectrum, whales can hear really, really low frequencies. So waves that have a really long wavelength. And this is what helps them to communicate over really long distances underwater. So once you finish this video, there are 2 worksheets on Show My Homework you need to download and complete. And there is also this activity on sound energy on Sam Learning. So once you finish the video, head over to Sam Learning, do this activity. There's 24 marks and 9 screens to fill in. And then complete those 2 worksheets. Make sure you're uploading those 2 worksheets to Show My Homework, or submitting them to Show My Homework to tell me and show me that you've done it. If you can't find the Sam Learning task, if you hop onto this PowerPoint and have a look at this slide and just move this picture, behind this slide there is a link that should hopefully work to the sound energy SAM learning task if you can't find it. So I hope you've enjoyed this video. Congratulations to making it to week 3. I hope you enjoyed your Easter holiday and managed to stay safe with family. Make sure you're keeping up to date with all the worksheets and anything like that. If you've got any problems at all, please feel free to email us. Our emails will be attached on the Show My Homework description of the task. Well done. Take care. Keep watching this video for the demonstration of how an oscilloscope shows sound, and then head over and do those 3 tasks, SAM learning and the 2 worksheets, please.
Okay, we're going to show 2 different kinds of change of sound using this oscilloscope. The one is changing the loudness, and if you look at the screen, as you change the loudness, the amplitude gets higher and higher. So now you can hear how loud it is. The amplitude, which is how high the wave is bigger. And the other thing that we can change is the pitch or the frequency. And when you change the pitch or the frequency, the wavelength gets shorter. So a very low sound has a long wavelength, and the higher the sound goes, the shorter the wavelength gets. And remember, the wavelength is the distance between the 2 crests. So as the sound gets higher, the wavelength gets shorter and shorter and shorter. And that's it.